Yes, you're welcome to Enock's videos. Today I'm dealing with some research tools. Many people carry out research, they get data, but do people have trust in your data? How do you build trust in people who are going to use your data? And how do you build confidence in people who are going to look at your conclusions? They are what we call the research tools, which I'm going to talk about in this video. The first tool is called Spearman's rank correlation. The second one is called Pearson's linear correlation. The third one is Simpson's index of diversity. The fourth one is chi-square test, and the fifth one is the t-test. With the knowledge of this, you'll be in position to come up with data that can be trusted and then conclusions which are accepted worldwide in the scientific world. I'll begin with Spearman's rank correlation, and I want to talk about this word rank. When you were still in secondary, a student who had the highest mark was always at the top, while the student who has got the lowest mark was always at the bottom. So the one with the biggest value is at the top, takes the biggest share. So there's an arrangement starting from the biggest to the smallest and vice versa. So in rank there is that sequential arrangement or serial arrangement. So when you're dealing with the Spearman's rank correlation, we normally deal with two sets of variables which are not normally distributed. For example, if one was to determine the population of species R and species S, this is species S and then this is species R, but using a quadrat. A quadrat, we all know a quadrat has four sides, can be measuring 1 meter by 1 meter, that is 1 meter squared. So if he throws the quadrat in the garden randomly and counts the number of species of R, for example, in the first throw he found out 38 of R and 24 of S. He threw it again, he obtained 2 of R, 5 of S. He threw it the third time, he obtained 22 of R and 8 of S. So is there a relationship? We really don't know whether there is a relationship. Let's look at the 10th throw. When he threw it the 10th time, he obtained 43 of R and 30 of S. So we as scientists want to know whether there is a relationship, whether there is correlation between the two species in the way they are distributed. One, we first of all test it using a scatter graph. We can plot the number of species of R against the number of species of S. So there's no rule which one should be on the y-axis and which one should be on the x-axis. Any way can work. What we want to prove whether there is any relationship. So a scatter graph can be used to check whether there is any relationship between two variables, like in this case of species R and species S. So after obtaining those values, we can further proceed and calculate and determine the rank of the individual species. For example, we look at species R. In the 10 quadrats, we look for the quadrat which had the highest number of species. Like in this case, it is quadrant number 4, which had 50 species, and we give it 10. Remember, we threw 10 quadrats, so it takes the highest value, that is 10. It is given the highest rank. It is given the highest rank. Then which one follows? Let's check. It was the 10th quadrant which had 43 species of R, and we rank it number 9. Which one follows? Let's check. Quadrant number 7 had 42, we rank it number 8. So we do the same until we reach the quadrant that had the lowest number of species of ara, and that's quadrant number 2. It had only 2, and rank it number 1. It is the least, had lowest number of species. So these values, the rank, just show which one has the biggest value, which one has the smallest value. The one which has the small rank, that means it had the smallest value or number of species. Now we come to species S. It was quadrant number 7 which had the greatest number of species of S. It had 36, so we rank it number 10. When we check, quadrant number 4 had 31, so we rank it number 9. So the rank tells us which one or which quadrant has the greatest number of species and which quadrant has the least number of species. The lower the rank, the fewer number of organisms that were present. The higher the rank, the greater the number of organisms that were present in the quadrant. I guess you understand what I'm talking about. So Spearman's rank correlation is always calculated using this formula. I guess you're seeing this formula. This is the formula we use to calculate Spearman's rank correlation. So in this formula, you can see we have 6 times summation of d squared n cubed minus n. So d stands for the difference in rank. Difference in rank. Then n represents the number of quadrats that were thrown. For example, in this case, they threw 10 quadrats. They threw 10 quadrats. So we have the value of n, but we don't have the value of d squared, so we need to calculate it. So we can use a table which can be constructed in this way. We arrange the number of quadrats that were thrown, and then we also fit in the ranks for the individual species basing on the specific quadrant. For example, in this case, quadrant 1 had rank 7, quadrant 2 had 1, quadrant 10 had 9. So we arrange just like we had in the previous table. We also do the same for species S, and then we can determine D by subtracting rank for species R minus rank for species S. The order doesn't matter. One might have had rank for species S here, and here rank for species R. But the order doesn't matter. Whether you get a negative or not, it will be catered for. In other words, to be removed when we do square. So when we square, we're getting only positive values, and then we need to obtain a summation of d squared, and in this case we are getting a value of 12. So after getting 12, we need to fit it in our formula, that is RS, that is the Spearman's rank coefficient, is equal to 1 minus 6 times the summation of d squared, which is 12, over 10 cubed, those were the number of quadrats that were thrown, minus 10, and the value which we are getting is 0.93. We can put it to 2 decimal places to be smart enough. Don't put very many figures, we only want 2 decimal places. This value is close to 1, and any value that is closer to 1 is more like, it shows that there is a genuine correlation between the two sets of data. That's what it shows. There is a correlation. There is a correlation. So this value, you can't take it for granted. 0.93, it means that the data that we have, or the number of species of R and the number of species of S, there is something, there could be some external factors that bring about that close relationship. There should be something in the environment that we shall have to discover in the next videos that I have to present. So we have RS values for a probability of 0.05. So we are saying that you use a correlation coefficient table to look up value of RS if your value of RS is greater than the value of RS value for probability of 0.5. you can say that there is significant correlation between your two variables. For example, in the other case, in our example, we have got 0.93, but the n was 10. So n was 10, but our RS is above 0.65. So this means that there is a significant correlation between the two variables, and in this case the variables are species R and species S. There is a significant correlation. I guess you have understood. You need this table in order to fully make a conclusion like we have just made. This is your exercise which I want you to carry out, Spearman's rank correlation, and find out whether there is significant relationship or correlation between species F and species G. This information is very important for your research, and in case you need help, you are stuck, don't cry. You can reach me on my WhatsApp. This WhatsApp is ever on, day and night. +256 775 56 52 63. However, you can also call. This number is ever on, day and night. Or if you don't have time of calling, you can send me an email on this, and then I will reply. Don't get stuck with your research. I'm there to help you, and thank you for listening. Thank you for watching Enock's videos. Yum 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 yum.